Hello, good afternoon everyone, and welcome to this session. This is the deep dive for Amazon Relational Database. My name's Toby Knight. I'm a Solution Architect Manager for AWS. I've been working for AWS for about 2 years. So what are we going to cover today? We're going to give an overview of RDS. We'll talk about some of the different engines you can use, the database engines and applications that we support. We'll talk a bit about security and the features included within RDS that help you secure your data. We've got a customer story here. We've got Steve from SportPursuit who'll be telling us about how SportPursuit use RDS to support their business. We'll talk a bit about migration. We've got a slot on metrics and monitoring to see how you can monitor your RDS instances to ensure availability and uptime. We've got a section on scaling. So how do you scale to handle variability of demand, for example, from your customers or growth in your business or vice versa. We'll talk a bit about backups and snapshots. So how do you secure your data? How do you provide for recovery, both automated and manual? And we've got a section on high availability. So let's get started then. So what is Amazon Relational Database Service? So it's a fully managed service that provides a number of different database engine options. Includes features around application compatibility, such as ability to use MySQL, Postgres engines, and so on. And the idea is that you can support your existing applications. So you can migrate in your existing relational database into RDS. RDS features instant provisioning. So at the click of a button in the console or via the CLI, you can instantly create an RDS database instance. And you can scale up or down, again, with a click or a command or via an API call. Our customers tell us it's very cost effective. And we've got a new feature that some of you that watch our blogs regularly maybe know about that we're going to talk about today, which is going to add to that. So yeah, I mentioned these database engines that RDS supports. So you can see here the engines that are supported by RDS. On the commercial side, we support RDS for Oracle. So you can migrate your Oracle data into RDS. SQL Server, for those customers that are using Microsoft for their relational database, you can use SQL Server on RDS. Again, open source, we've got MySQL, Postgres SQL, and MariaDB. And there's Amazon Aurora, which you probably heard Werner talk about in the keynote. So this is where we've redesigned the relational database with the resilient performance storage tier that's got MySQL compatibility and now in preview Postgres SQL compatibility. So a quick look at Aurora versus MySQL, just to give you a flavor. This is often a decision that customers come to us with. Should I be using Aurora? Should I be using MySQL on RDS? So here are some of the stats that give you that comparison. As you can see right at the top, Aurora supports a large number of replicas, which gives you high availability. It gives you horizontal scaling to support a number of read replicas and really scaling out your database at that horizontal level. The replication performance, so if you go for a multi-AZ or resilient multi-AZ solution, again with Aurora, the replication performance impact is a lot lower. And if you look at the storage stat, it's one I'm going to call out there. So Aurora scales up to a 64 terabyte database size. So I've worked with some customers that have some pretty large databases, but I don't know anyone yet that's found that to be a constraint. But I'm sure that will happen, and our engineers will have to work on that in due course. So again, some of the decisions that customers bring to us are around the trade-offs as using RDS versus installing your own chosen database engine on EC2. And I think it's important that we are open about what those trade-offs are. For some customers, installing MySQL or SQL Server on EC2 will be a better option. And some of the trade-offs that we mentioned here, so with RDS you have a fully managed host and operating system, which means you have no access, limited access to the host operating system. So certain types of database administrators in the past may have accessed the host operating system to run certain scripts and boost performance and so on. You have limited ability to modify the configuration of the host OS. Around storage, RDS provides a fully managed storage, and we've talked about some of those storage limits already. And the fact that it's fully managed implies some constraints, and some of those storage limits are mentioned here. So SQL Server is a maximum 4 terabyte database size at the moment. MySQL on RDS is a 6 terabyte database maximum size limit. Many customers rely on RDS to support their applications. I focus, in my role, I work with retail customers here in the UK. Many retail customers use the RDS for their e-commerce workloads and for other applications. And you can see some of our customers here. We've got SportPursuit there. Steve's going to tell us about that in a bit. We've got Trainline. We've got Trinity Mirror that use it for some of their news websites. Security. Security is a massive concern for our customers, and we aim to develop features and facets of the platform that support our customers in their desire to secure their customer data. So let's start with VPC. So RDS resides within a VPC, and that gives you certain controls and mechanisms to restrict access to that database. In this diagram here, we've got a single instance, non-multi-AZ, it's a single instance of RDS. We've got it sitting within a security group in the middle there. We've got a range defined around that. We've got private addressing sitting within a single availability zone. So VPC gives you the ability to secure that data, control who has access to it. And it gives you the ability to use connectivity like Direct Connect, which gives you high bandwidth connections to your on-premise data center or to your own offices. We've got VPC peering that allows you to connect different VPCs together and control access between VPC A, VPC B. VPNs often used either as a temporary measure or before customers or customers that don't need Direct Connect, they can use VPN to connect their own site to AWS. So in this way, one of the use cases you have is you have an RDS database that may not be used by a public internet-facing service. It may be used by one of your own internal offices. And you can then use entirely private network connectivity to support that. So we talked a bit about security groups already. We mentioned them. So this slide gives you an idea of the level of control you've got with RDS and security groups. So here we have an RDS instance, and we've got two use cases here. We've got corporate administrators, and we've got an application tier. So both of these source systems, or clients, if you like, are connecting to RDS as a server. And we've got an example security group configuration here, which shows the source ranges and ports which are permitted to access. So you define the security group. You define which ranges and ports are allowed to access your RDS instances. Many of our customers have regulatory and compliance requirements, and the RDS teams have worked to get the RDS service and the different database engines certified on many of the standards that you see here today. Gov.uk is obviously very pertinent to our public sector customers. In the US, FedRAMP's important, and generally ISO 27001 is a recognized standard of quality. If we then break down that compliance matrix by database engine, you can see that we're working with our partners in our compliance teams to ensure that those different engines are compliant. And in many cases, the certificates that are not shown here for a particular engine, we're in the process of getting those engines certified. So another way that you can secure access to your database is by encrypting the data in transit from the client that connects to RDS as the server. And we provide for that within RDS using SSL. So this gives you the ability to encrypt data in transit, say, for example, from your application server to your RDS instance, or from a DBA's workstation to your RDS instance. And we've got a sample command here using the MySQL command line utility that then pulls down, or you have to pull down the SSL certificate bundle, and then this command line shows how you can do that and encrypt all of that data in transit. So it really gives you control over ensuring that that data is confidential and mitigating the risk of interception. And this is available for all 6 engines of RDS. again, another feature that's been demanded by many of our customers and is encryption of data at rest. Now, in RDS, this is provided for within not only the database instances, but also the associated RDS objects, such as read replicas, snapshots, backups. There's no additional cost, and you can use the key management service within RDS to manage this on your behalf. So how does that work? So the AWS Key Management Service gives you a master key in your account. And you can either use the default key, and we'll go on to some configuration in a minute, or you can create your own custom key to encrypt your RDS objects. So for those of you that like the command line, I'm not going to do a demo, but if you want to create an encrypted RDS instance, here's a couple of examples of how you go about doing that. The top example will create an RDS instance using the default encryption key. And in the second example, we're creating an instance where you specify the KMS key ID. So that gives you the ability to customize which other services and which IAM users have access to that KMS key. So some new features have been launched for RDS in this particular area. So I'll quickly skip to the last bullet point. We'll go backwards on this slide. And you can now copy encrypted or unencrypted snapshots across regions. So we've been adding features and innovating on your behalf. We've been listening to what customers tell us. And RDS customers tell us that encryption is important, and they want to be able to potentially copy encrypted snapshots across regions. So we've provided that now. I think the top two ones are quite important. Once you've enabled encryption on a database instance, you can't remove it. And once you've enabled encryption on the database instance, then all the other associated objects need to be encrypted as well. So how do you limit which administrative users have access to managing RDS, have the ability to delete RDS instances, to start and stop RDS instances, and so on? So identity and access management gives you those controls. Traditionally, the access to and control to the data within the database was controlled by database grants. We'll have an update on that in a minute. But in terms of the management and administrative actions and use cases, you control that using identity and access management. So you can use IAM to set up RDS role-based access control, so you can have read-only user groups, you can have full rights DBA access, and those users then have the option to stop and start your instances, delete your instances, create snapshots, and so on. And here's a couple of policies that give you that example. So within your identity and access management policies, here are two sets of ACLs that describe that read-only model and then that full access model. And by creating these policies and assigning them to IAM roles, you can then add users to that, enforcing a standard-based RBAC model. So here's a new feature I wanted to talk about today. And, oops. So now you can use identity and access management to control database authentication. This is currently available for MySQL and Aurora. It's already launched. It's generally available. But this, I guess, brings identity and access management into your regular database administration. Say, for example, you've got a 3-tier web application, and you can now control your access from the application tier and manage that using identity and access management. So here's a quick step-by-step on how you do that. And all this is available online in our documentation. So you can create your RDS database instance with IAM database authentication enabled. You create the user in your database. And there's a special command or flag that you use to create that user and enable it for IAM authentication. You then attach an IAM policy to the IAM user or role. You get an authentication token, and you can connect to the database. So again, this gives you more control, more visibility of who's accessing the database, and so on. All of the documentation's online here. So thanks very much. I'm going to return for the end of the presentation, but I'll now hand over to Steve from SportPursuit. Here you go, Steve.
Thanks, Toby. I'm Steve Blake. I'm CTO at SportPursuit. Been there for about 5.5 years now. For those of you who haven't heard of SportPursuit, we were founded in 2011, and we're a flash sales business selling sports equipment. That's from some of the best outdoor and sports brands that the world has to offer. And our mission is to give access to sports enthusiasts to the best kit available at affordable prices. Originally started predominantly in the UK and have now grown up the user base to almost 3.5 million. So yeah, going pretty well from a user growth point of view. We're currently in the process of expanding internationally. So done translations into 7 languages and are offering 8 currencies and are shipping to over 40 countries around the world. We've also seen some pretty good growth in terms of revenue, so growing at about 40% year on year, which is keeping the investors pretty happy. Apart from offering great deals to customers, we also offer an interesting proposition to the brands. So listed there are some household brands, which I'm sure many of you would recognize, but we provide a really interesting marketing opportunity to those brands where they can market to quite a large user base of sports enthusiasts, but it's also a great channel for clearing excess stock without sacrificing brand identity, because the last thing brands want to do, particularly if you're a high-end sports brand, is to have last season's stock splashed all over eBay at half price. In terms of our AWS infrastructure, it started with quite humble beginnings, I must say. So this was about the time when we were just trying to prove the business model. And some of the services which AWS now have, Werner was talking about this morning, like 1,000 services launched last year. Like back then, they weren't really available. So all we had were 2 EC2 instances, one with our e-commerce platform on it and one with the MySQL database running. Since then, to support the growing user base, our architecture has expanded, and luckily AWS has been there to support us on that journey. So right now, this is kind of a simplified high-level overview of our architecture. So we've got 3 kind of core applications. One is the e-commerce platform, and then we've running an API, which we use for powering our iOS app. And then in the back end, we've got an ERP system for stock management, integrations to the warehouse, etc. And all of these systems have got a relational database associated to them. So on the API and the e-commerce side, we're using MySQL powered by RDS. And for the ERP system, we're using Postgres, also in RDS. Then we've also got an open source analytics platform that's also got a MySQL backend. And big project that we're currently working on is kind of moving all that data into a centralized store, and we've chosen Redshift to do that. So I'll get onto that in the end of the presentation. So just to give you an idea of kind of our RDS estate, it's not massive, but we're at least putting it through its paces. At any one time, we'll have about 25 instances running, roughly 7 terabytes of data stored across those instances, and in peak periods, doing throughput of about 100 megabits per second. But yeah, it can definitely handle a lot more than that, so good choice for scaling. Before we used RDS, we're just running MySQL on EC2 instances, and that resulted in quite a lot of additional overhead. So first one is just manual database administration, having to manually create slave replicas, having to manually solve replication issues, etc. And then also doing minor version upgrades, all required someone logging into the server and doing an update. Another thing which everybody has as a challenge, or not a challenge anymore, but doing backups. So actually, quite a few years ago, we had a daily backup running, and realized that at a certain period every evening, around about 2 a.m., sort of UK time, we experienced quite a lot of database load, and it turned out that it was actually just the MySQL dump on a daily basis. So that's something which is a commodity now. And then refreshing staging environments. So our product catalog and sales offering on a website changes on a daily basis, and we want our staging environments to be reflective of the production environment. So that's something which we had to do manually, and was quite time consuming. So things that we've, like from moving to RDS, things that it's really helped with is reducing some of the overhead of manual database administration. We're able to create slave replicas with ease, able to do version upgrades with ease, all within maintenance windows. You also get daily automated backups out of the box, and you can do manual snapshots of those automated snapshots whenever you want to. And then the refreshing of staging environments is also a lot easier now. So generally we'll take a snapshot of the database, anonymize that, and then restore it in a staging environment. It's actually, when chatting to Toby, it's something which I feel is a challenge that a lot of companies would have, and it would be quite interesting to offer that as a service within the AWS suite. So some of the lessons learned, I mean, this talk is more about giving an overview to RDS and some of the technical features. So I wanted to try and just give people some interesting feedback on our experience. So firstly, if you do have replication errors, this is the same if you're just running MySQL on a direct server. Don't ignore any replica errors. We actually had a situation where we had a replica that we were creating for doing a big data transfer that wasn't really being used by a production system, but it had a replication error. And because of the binary log disk usage on the master was increasing, we actually ran out of storage on the master, which wasn't good. So yeah, another thing, if you are using MySQL, try avoid using MyISOM tables. If you do have to, then you'll probably get warnings in the AWS console, but try and use the InnoDB storage engine if possible. And then another thing that we've found that since moving to having 2 accounts, so we've got production AWS accounts and a dev account, just from security and restriction point of view, moving snapshots between those accounts requires an extra step from an automated snapshot. Some of the sticking points which we've had, lessons learned. The first one is more of a mindset change, not particularly related to RDS, but using cloud computing as a whole. When in touch with the AWS support engineers, who are generally very good, a lot of the advice is just kill off that instance and start a new one. And coming from a kind of traditional sysadmin background, it's a bit counterintuitive, but once you get your head around that and think that it's not just about a single element in the system and more about the overall health of the platform, then you should have confidence that you can kill off one RDS instance if it's a replica and a new one will be created, or if there's an error with the master, a replica will be there to take its place. Then there's also some time taken to do upgrades and any changes, so bear that in mind. If you are doing major updates, do them in out of hours or like out of peak periods. And you also do need to do a hard reboot of the instance for option or parameter group changes instead of just doing MySQL service restart. So upcoming projects that we're looking at related to RDS within SportPursuit. There's been quite a lot of chat about Aurora. Sounds really exciting and quite keen to test it out on our platform. But obviously want to test that it is compatible with an e-commerce platform, but I have no doubt that it will be. And then we also, I mentioned in the beginning, we're working on a BI and reporting project where we're using RDS and moving data into Redshift. So this is kind of a high-level overview of what we're trying to do. We're moving data from various RDS database instances into AWS Redshift, and have got the board BI reporting tool on top of that. But then in addition to that, we're also pulling data from various other service providers. So our email service provider, payment service providers, and other platforms that we're using for marketing, all into one central location. And doing things like payment reconciliation on a monthly basis has become so much easier. To do the moving and shifting of data within AWS, we're using the pipelines, AWS pipeline service, which is really easy to set up. And yeah, it's quite a useful tool. But yeah, that's about it from me. Generally, great experience with RDS, and I'm around here for the rest of the day if you do want to chat to me. Thank you.
Thanks very much, Steve. Thank you. Very interesting. It's always good to hear from customers that are using the service as well as AWS people, so I appreciate that. So the next section in the presentation, we're going to talk a bit about migrating onto RDS. How do you go about migrating? And taking a step back and looking at previous approaches to migration with relational databases, typically this would have some complexity and some cost involved. One of the challenges that customers bring to us is that they are tied to a database platform, and not only for the reasons of licensing that we heard about earlier today in the keynote, but also to do with legacy schema objects, so stored procedures, PL/SQL, etc. And a migration can often incur application downtime, and nowadays that finding any maintenance window or change window is difficult for a lot of businesses. So AWS approach and response to the challenges that customers face around database migration is around a two-step process or approach. The first is looking at the database schema. So we provide the AWS schema conversion tool that allows you to examine your source database, whether it's on-premise or in the cloud, and then pick out your target database and then migrate your schema over. So looking at tables, columns, data types, and so on, and mapping those in the best way possible. And step two is around the AWS Database Migration Service, which actually moves the data and syncs the data from source to target. So the schema conversion tool overview, this is a bit of a screenshot, and I was having a bit of a play with the tool in preparation of this talk, so I can tell you it's very easy to set up. And I'm a manager, so if I can do it, it must be easy. So yeah, you can see on the left you've got a source database, and on the right you've got your target, and in the middle we've got some of the properties and SQL involved in doing that schema migration. The database migration service supports all 6 of our engines, and it doesn't have to just be a one-time migration. It can be a continual data migration that can keep your source and target in sync. And that allows you to schedule your cutover when you're ready. And you can replicate to and from sources and targets around EC2 and RDS. So you have that flexibility, whether that's AWS, whether that's on-premise. So it really gives you that flexibility to run the migration the way you need to. Oh, this is one of those building slides. Okay. Oops. So again, we talked about how the database migration service keeps your applications running during the migration. So how do you do it? You start a replication instance. You connect to your source and target. select the tables and schemas that you want to replicate, and the migration service will migrate the data and copy the data over to your target and keep them in sync. And you could be using VPN there, it could be Direct Connect as the underlying connectivity. So it gives you a very flexible migration approach. Not only have we talked about the different engines that are supported, but it gives you the ability to take one source and migrate it to multiple targets, or vice versa. You could consolidate multiple data sources into a single target. You can also be selective. So for example, you can migrate certain tables from your source database to one RDS instance and other tables to another. So the next challenge that customers tell us about and the service team have been working hard to address is around metrics and monitoring. And some of the areas that we look at with RDS in this topic is the RDS metrics themselves, and we'll have a quick look at those in a minute. We've got event notifications that will give you reporting, notifications, and alerting on some of the key events within RDS. We'll have some examples of those. You've got log files from the RDS instance operating systems, and then there's CloudTrail. So remember, CloudTrail can give you an audit log of every single administrative action that's carried out against RDS. So it's very powerful in terms of that audit and compliance. So RDS metrics are very easy to access through the management console. I'm not doing a demo today, so it's just a quick screenshot from the management console. But you select your RDS instance, and you can show the monitoring in various formats. And here's an example of what that might look like. You get some graphs. Now, again, I want to be transparent with you guys. It's about education. So RDS standard metrics and even enhanced monitoring will not give you a visibility of every single metric at the database engine layer. And so sometimes customers use third-party tools to add to that and give you that additional granularity. So standard metrics, we've got some examples of what you get here. So what you'd expect to see, so things like CPU utilization, free memory, queue depth. And then enhanced monitoring. So that gives you a much longer list of metrics that you can use to measure the performance, quantify the performance of your RDS instances. And we've got a full list here. So really down to quite a high level of detail. And as I said, if you want more than that, there are a range of third-party tools available. Some of them are available on the AWS marketplace. So I'd encourage you to have a look at those as well. I mentioned event notifications, so this gives you the ability to alert on key events that affect your RDS instance or are taken out on your RDS instance. So for example, we've got a deletion of the RDS instance, failover from a primary to a secondary, failure of the instance. That's obviously going to be a key one you're going to want to report on. And one of our principles as solution architect teams at AWS is design for failure. So the multi-AZ component of RDS helps you do that. We want to help you make sure your architectures are resilient and can, as Steve said, I guess, survive the failure of an individual component. Other events here, we've got things like backup and restore as well. So you can use SNS to channel and get visibility of these alerts. And so SNS will give you the ability to send those event notifications to email or SMS to a mobile phone, etc. One of the other areas that's important for RDS customers is scaling. So traditionally, with databases in particular, scaling was always a bit of a challenge. And it was always a question of scale up in most cases. And we've added a number of options here that I think will make that much richer. So the first one for Read Replicas is the ability to scale out Read Replicas for your RDS instances. And this gives you the ability to offload those read requests to your RDS database onto those Read Replicas and really scale out horizontally where you can, taking the pressure off the master node. And you can do that cross-region, as we've shown here. So the Read Replicas don't have to be in the same region as your master database instance. They can be in other regions, and that gives you the ability to put that data closer to your end users. And so Read Replicas are available for these engines here, as you can see. So MySQL, MariaDB, Postgres, and Aurora. And for Oracle and SQL Server, you're going to have to look at other options depending on what's available with those database engines. So once again, creating and I think that should read promoting. Sorry, it's a typo. Creating and promoting Read Replicas is very easy within the console. You can also use the CLI, but this is how you do it in the console. And here we are within the CLI. And for anyone that's new to AWS and you want to learn about the API, I think the CLI is a great way to go about that. If you have a look at the CLI help file for a particular service, as a practical tip, it gives you great visibility of the capabilities that are exposed by that service. So for example, if you want to learn about RDS, go have a look at the CLI for RDS. And the other tip I'll give you there is the CLI binary you have to download. So as we release new features, you might need a new copy of the CLI binary to support those new features. So if we release something new and it's not working on your CLI, then check you've got the latest version of the CLI download binary. And here's an example of some of the flags and options that are available for creating a new database instance read replica. So yeah, scaling up or down, you might do that for a number of reasons. It may be because your website's getting more popular. It may be because it's the weekend and you want to save money because not many users are using your service. And it gives you the ability to control cost. So you can modify your database instance to scale up or down. And what that'll do in the background is effectively stop it and start it and restart it on a smaller or a larger instance, depending on what you specify. And you can see the flag there, the checkbox. You've got the option to apply it immediately. If you check that, it will reboot it and start it up on that new instance you specified. If you don't check that, then it will apply those changes in your next maintenance window. And the maintenance window with RDS is when patches get applied. It's a weekly window, I think, off the top of my head. It's weekly, and so that's when patches will get applied, and if you leave this box unchecked, that's when that change will get implemented. So a new feature that I'm very excited about, it's quite basic, but I think it's going to be helpful, particularly for cost optimization, and this is now generally available, is the ability to stop and start your database instances. Some of these features, when they come out, you sort of think, oh, didn't we have that before? But we do now, so I think, again, practical advice, if you're running RDS test and dev, stop those instances outside of business hours when the developers aren't using it. You could rig that up to a Lambda function. You could automate it on a schedule. You could put it on an IoT button, whatever you like. The last person to leave the dev room, press the IoT button on the wall and switch off the DB instances. So there's simple, practical ways you can reduce your spend. And again, one of the things we look to do as solution architects is cost optimize our customers. So how does it work? So again, using the CLI, we've got a very simple command. Quite good, isn't it? RDS stop DB instance. Very simple. And you just specify your database instance identifier there. And in the console, you select the instance and you select stop. So just again to be explicit, once it's stopped, you'll still be paying for the storage, so the EBS volumes that database resides on, but you won't be paying for the compute while it's stopped. And start again. So there we go. So there's the commands. And again, if you have got an old version of the CLI binary, you'll have to update it to be able to use this CLI command. So back in the hazy past when I was working in infrastructure data centers, pre-cloud, every now and then you find out that someone had forgotten to back up a database. That's not a good place to be. If it's all running, then you're fine. But we've got automated backups that help prevent that. But you've also got manual snapshots. So as we said, we've got a scheduled daily backup of the entire instance. We archive the database change logs, and those are stored for up to 35 days. So when that backoff kicks up, if that's a single database instance, the I/O will be suspended in order to make sure it's consistent as that backup is initiated. But if you've got a multi-AZ database, then it will simply take the backup from the standby database, so there's no I/O suspension. So Aurora handles backups in a slightly different way because it's got a re-architected storage tier, but it still gives you a point-in-time restore, and there's no impact on database performance of carrying out those backups. And again, we have a 35-day retention for those automated backups. If you need to retain backups longer than that, then you can use manual snapshots, and you can design or decide your own data retention policy around that. And here's a screenshot from an RDS Restore. The first point's important there for your DR strategy, and when you're designing a disaster recovery or fault tolerance strategy for RDS, remember that if you do an RDS restore, it's going to restore that to a new database instance. So your application tier, if you're reusing the existing application tier, you may need to reconfigure that in order to point to the new RDS instance. So snapshots are backed by Amazon S3, so it's highly durable, 11 nines of durability. And here are some of the use cases. This is a manual snapshot. You can right-click on your RDS instance in the console, or again, run a CLI command. And some of the use cases might be, you're just about to do a schema update on your database. Good time to back it up, I'd say. Or you're just about to roll out a new version of your application that might have a database impact, and so on. So you get the idea. Again, another good use case there is if you're just about to terminate a database and you're not quite sure, might I need this again? Make a manual snapshot before you do that. So high availability. I'm old enough to remember physical servers when if we wanted a highly available, a multi-data center database service, you'd have to go and take the DBAs out to dinner to get log shipping set up, or go to your storage vendor and get him to sell you some SAN replication. So we take care of all of that for you. But let's step back a little bit. So with RDS in a single availability zone, again, good for test and dev, quite cost effective. We've seen this slide before pretty much, but you can see there we've got a single instance and we've got a single Amazon EBS volume. So quite a few single points of failure there. So then we've got multi-AZ. So we've made this very easy for you, and I still think this is one of our most brilliant features. When you create your database instance, you can just tick a box and say it's multi-AZ, and we'll spread that across 2 physical locations. We'll take care of replication for you. We'll even handle automated failover for you. So if the primary instance fails, we'll handle failover to the secondary and make that endpoint cut over. Replication of the storage, and that's synchronous replication, by the way. And here's a slide that shows how that works. So let's say we have a failure of the primary node here. There's the failure. It might be a host failure, so maybe the underlying host has failed. It might be a storage failure. It could be an AZ failure. Any number of failure scenarios that this protects against. RDS will then detect that failure, repoint the endpoint to the secondary. That will be made the new master. And then it will go ahead and recreate another secondary. So that's multi-AZ, which is available for database engines such as MySQL and many others. Aurora handles high availability in quite a different way. As I've said, we've re-architected the storage tier for Aurora. So the storage is spread across 3 availability zones with 2 storage nodes in each zone. So the storage tier is by its nature resilient, and the Aurora nodes are, again, spread across availability zones. We've got primary and secondaries to provide resilience at the node tier as well. So the point of this slide is that Aurora with the MariaDB driver provides a much faster recovery time. And you can see some of the phases and some of the events that take place in a failover with MySQL as opposed to Aurora with MariaDB. It gives you a much faster failover time in total. Some of our customers want some pretty fast RTO and RPO, or recovery time objective, recovery point objectives. And so these sort of incremental changes and improvements can mean quite a big difference to them. So thank you very much for listening. That brings us to the end of today's presentation, and thank you for Steve for joining us. I'll be available on the AWS Ask an Architect stand after 3:30 today. Thank you, everyone.